Hello. Today we're going to look at what the first derivative tells us about the graph of a function and about the function in general. So first off, let's suppose that I have a first derivative or function that looks like this. The derivative function looks like this, and for simplicity's sake, I'm going to call this value x1, x2, x3, x4, x5, x6, x7. Okay? So, this is the derivative graph, not the graph of the original function. This is the graph of f prime of x. And from this, I want to know where is f of x, the original function, increasing. Now, f of x is increasing where f prime of x is positive, greater than 0. Therefore, looking at my graph over here, the first derivative is positive between x1 and x3. It's positive between x5 and x7. So this is where my original function is increasing. Similarly, f of x is decreasing on the interval from negative infinity, or intervals from negative infinity to x1, from x3 to x5, and from x7 to infinity. We can also use the first derivative graph to tell us where we have relative max or relative min for my function. Where does f of x have a relative max? Now, we get a relative max when my function, the derivative, changes from being increasing to decreasing. Relative max, f of x goes from increasing to decreasing. Whereas for relative min, my function goes from decreasing to increasing. So, at x1, my function was decreasing, my function was increasing at x, as we went across x1, it went from decreasing to increasing, and so therefore I have a relative min. Let me do all the relative mins. At x1, again, when I go from decreasing to increasing, at x5, and when I go, let's see, that's it. Where do I have a relative max? I have one at x3, when I go from increasing to decreasing, and at x7. Notice they are not at x2, x4, and x6. Those are absolutely nothing in this particular situation. Now let's look at a function without the graph and see how we can deal with that using what's called the first derivative test. First derivative test determines where we have relative max, relative min. And so let's suppose my function f of x is equal to x squared plus 4 over 2x minus 3. Again, in order to determine relative max, relative min using the first derivative test, I need the first derivative. F prime of x is equal to bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared, which gives me 4x squared minus 6x minus 2x squared minus 8 when I distribute. Denominator stays the same. I get then 2x squared minus 6x minus 8 over 2x minus 3 quantity squared. And if I want, I can first factor out a 2 in the numerator. And then go ahead and just factor the polynomial. This factors nicely. We get 2 times x minus 4 times x plus 1 over 2x minus 3 quantity squared. Now, in order to use the first derivative test, we need a sign table, an algebraic sign table. And what we will do is put every value where this derivative is either 0 or doesn't exist on the number line. And so in this case, I have the values of -1, I'll put them in order, positive 3/2, and positive 4. And we want to know is what is the algebraic sign of this derivative in each of these 4 regions. We can do this 2 ways. In this case, because this factors nicely and it's simple, I can just actually take each individual factor and consider what happens to each factor. If we don't want to do that, we can also just pick a random point in each interval. This is probably what you've been told to do previously. Pick a random point in each interval and put it into the derivative and see what happens, whether it's positive or negative. In this case, because I have nice factors, oops, this should be squared. 2 is always positive. X minus 4 is negative until you reach 4 and then becomes positive. X plus 1 is negative until you reach -1. The square is positive in each of these regions. Overall, that gives me positive, negative, negative, positive, which means, again, this is the derivative. So like in the graph example, this means my graph is going increasing. This is decreasing, decreasing, increasing. Therefore, at -1, I have a relative max. Notice 3/2 is not in the domain of the function, so we don't have anything there. I can get rid of that value in terms of worrying about max or min. Nothing happens that way there anyway. And in this case, it decreases and then increases, and so we have a relative min. If I wanted to know intervals where I'm increasing and decreasing, the original function is increasing on the interval from -infinity to -1, and also from 4 to infinity, and it is decreasing on the interval from -1 to 3/2 and 3/2 to 4. You cannot include 3/2, it is not in the domain. So it's not decreasing on that value. Okay?